This is the tutorial to help students who need to redo their Work Made Easy and Inclined Plane lab homework. Please feel free to stop the video at any point if you need to catch up. Like all tutorials, I'll be giving you help and assistance, but I will not be giving you full answers, so you need to make sure that you're following along. Yesterday in class, you were told to write down the ramp height and the force from the lab that we did Friday on inclined planes. And mind you, this is perfect world data. We wrote the formula together. So for number 2, in step 1, you're asked to abbreviate the formula. So I'm going to put D for distance times F for force. Yesterday, you were told to highlight the correct distance traveled for the front page. When there is no ramp, we use height because we are lifting the load straight up and down. So we'd use height. This is why you highlighted height here. Now for short ramp and long ramp, you're no longer going to use the height. You're going to use the length because that is the way the load traveled, this way. So in class with your highlighter, you no longer are going to highlight the ramp height anymore when you're talking about the short ramp. So this second line represents the short ramp. Here, and this is the long ramp. This is the length. So we'll be using the length when talking about ramps versus the height when we're talking about no ramps as the distance. Force will stay the same. So by looking up at the distance for no ramp, without a ramp, you're going to use height. You should write down 0.15 meters times the force. Look up here, the force for no ramp is 5 newtons. Now it's your turn to solve the rest of the problem. In your calculator, you're going to put 0.15 times 5, and you're going to put your answer here in Newton meters. Don't forget to put your unit of measurement. All right, now for 3 and 4, you are referring to the short ramp and the long ramp. So just like you did up here, you're going to write the formula and abbreviate it. D for distance times force. Now, this time, when you look at distance, we are no longer going up the height. That would only be with no ramp. We're going to go up the length. So the block of wood went from the ground and it slid up the length of the ramp. So what we highlighted in class was 0.7 meters for the short ramp. This is the distance we're going to use, not height, because we didn't travel this way with a ramp. We traveled this way. So your distance should be 0.7 meters times. Now we're using the exact same column for force, 1.07 newtons. So times 1.07 newtons. Your turn. Please use your calculator to multiply these two numbers and, of course, add the correct unit of measurement. Number 4, we are using the long ramp. So we are looking at this data here on the very last row. We are not using height because when we used a long ramp, it didn't go this way. It went this way. So write distance times force. Look back up at your graph. Here is the distance, not 0.15. I would like for you to do this on your own. The distance is going to be the length of the long ramp. That is on this bottom row here. What 2 numbers did you highlight? Number 5, we did this together as a class. We also did number 6 as a class, but I'm going to review. You're going to write down the formula. It's okay to abbreviate L divided by H. You're going to plug in the formula. We reviewed in class that when you are measuring the height of the ramp, there we go, but there was no length. So what's the equivalent for no length of a ramp? Or the same thing for a number that is nothing. It is 0. So you would not put anything for length. You would just put in 0 divided by, now the load traveled from the ground to the top of the books, aka the truck, it's going to be found in this first column. You're going to write down 0.15 meters. Divide, and 0 divided by any number doesn't work because there is no mechanical advantage, aka 0, because there's no ramp. So there's no advantage to using a ramp if you're not allowed to use a ramp. Number 7, the mechanical advantage of the short ramp. You're going to write the formula for mechanical advantage up here, length over height. Now look at your data table. Here is the short ramp here, this middle row. Here is the height, here is the ramp. So I'm going to put down 0.7 meters divided by 0.15. You're going to divide, use your calculator, press 0.7, the divide sign, 0.15 to get your mechanical advantage. Round up to the hundredths place. I'm going to let you do number 8 on your own. You're going to write this exact same formula. You're going to plug in the length here and the height here and divide. Put your answer at step 3. For number 9, look at all 3 answers. 1, 2, 3. Which one had the greatest or the highest number, aka the highest mechanical advantage? For Bart Simpson, so in this reading, I've given you quite a bit of information. I'm going to have you draw a ramp. Now, by reading this information, right, it tells me how high the ramp is, and it also tells me how long the ramp is. So 10 and 4. Now think about this. When a skater goes up and down the ramp, are they going straight up and down with the height? No. So we don't want to use the height just yet. We want to use the length of the ramp. So write your formula for work. This is going to be found number 1 here. D times F. Look at how long the length is. 10 meters long. Then the force is 400. Multiply those 2 numbers. And of course, don't forget to write the correct unit of measurement. All right, the reason why I had to give you height here is because the ideal mechanical advantage formula has to have both length and height. You're going to write the mechanical advantage formula. Look up at number 5. What did you write down? Now plug in the length here on your drawing, which was 10. This is the length. And then this is the height. So length this way, while height is this way. Divide and put your answer there. Please turn into me with your corrections. Take care.